All right, so in the end of lecture one, you learn about different types of green infrastructures. Now let's see how much you learn. So what I'll do is I'll pose some question here. You can pause the video so that you can see, give a thought, and then you see the answers. The first thing is which one of the following infrastructure is a gray infrastructures? So in the left side, you see these parking lots and with a lot of parks here, car. I'm considering this, and here is you see the same parking lot. Both provide the same functions, but one of them have some other design criteria. So you can pause the video now and think of the right answers. All right. I hope you have given a thought. As you can see here, the answer is this. So this is a green infrastructures, not just because there is a plant, but also the provide of the space which has allow water to be drained into. So that's even without plant having that swell would also consider as green infrastructures. But here the water is basically going everywhere. There is no obstacle for water to slow down. So this is gray infrastructures. So the homework one, which is basically homework one is the reason I call it homework one is this is also connected with your projects. So every end of the lectures, I'll ask you to write certain amount, like I have one paragraph or two paragraph. That's basically is your project report. And so when it's connected at the end, it becomes a story that I have in mind. So at the end of the first homework, you should write one paragraph, one which is half page, summarizing how and why green infrastructures can help fight negative effect of climate change related to water quality and quantity. So you have to explain what is green infrastructure or what is climate change, how climate change have negative, what are the negative effect of climate change on water quantity and quality, and then explain how green infrastructure can reduce that. So just like, again, half page, not too much. And then write one more paragraph about how green infrastructures may help store water or reserve the water as a reservoir, as a reserve for firefighting activities during wildfire in wildland urban interface. So again, the type of things you should consider here is the storage. So that means it could be rainwater harvesting or rainwater capture systems or system. So think of that, how we can integrate those. So again, it's a thought exercise, just one paragraph, and I'm going to expand that. So now you can pause the video and think of it a little bit more before I show you how it works. All right. I hope you have the chance to think about it. Here is the things. So climate change, what it does, increase the rainfall intensity, it decrease the rainfall frequencies. So that means you have a prolonged time when there will be no rainfall. And then there will be rainfall, but it will be so heavy that it's very hard to capture them. So because of change in hydrology, what happens is you have less water storage. And whenever you have lots of rainfall, the design, the engineering system that we design is simply failed to capture them. So that means over time we capture less water, and we also have longer period of time where we don't get any water naturally to replenish those systems. So that means consequently there will be less and less water for us to reuse for a long time. So what green infrastructure can do is basically design in such a way that it can capture water even at those high intensity, or it can capture water for reuse in a dry time. For instance, if you install a lot of green infrastructure in Los Angeles in different locations, those increase in filtration can recharge groundwater, which you can use that groundwater in a dry period. Similarly, climate change, because increased rainfall intensity, increase the overland flow. That means when you have a lot of flooding and a lot of increased flow, that can cause erosion and pollutions. By slowing down or limiting the flood, you can also limiting the pollution issues. So here I will show you how exactly green infrastructure achieve that. So this is one example of green infrastructure is a biofiltration system. So what you can do is this is a design again, this is a filter media. and this is plant, and this is the depressed area, and this is the size. So there are a lot of factors you can change for to accumulate future climate. As I said, if the imputation rate increases, what you have to do, or when the rainfall intensity increases, you get very high amount of rainfall. When you get high amount of rainfall, you have to size them properly to capture a lot more water. So one way to do that is by increasing the size. So increase the size, increase the depth, and also you can have a filter layer which has high K value. High K value means high hydraulic conductivity. If you are high hydraulic conductivity, even you have lots of water coming in, water will infiltrate much faster. Um, and so that by changing that, you account for infiltration capacity. You can match the infiltration capacity to the inflow capacity. That way you can maintain that. And also climate change being a lot more pollutants because of high erosions and high flooding. So you have to also find a way to degrade pollutant much faster. So that means you can add some kind of amendments that could improve the degradations. So this is why I call any kind of infiltration system, you can improve it by producing or improving 3K. Is a story of 3K. First K is hydraulic conductivity, increase hydraulic conductivity by changing the size of particle. So you can increase the size of particle by adding gravel, not gravel, sand, and some kind of other porous structures. By controlling the size, you control the K. And you increase the absorption capacity by adding more reactive media like biochars, another aspect. So those basically add more absorption, biochar activated carbons, or any other reactive media. So that means you have this wood basically absorbing absorbing more media, more pollutants. And in long term, you can as the pollutants are absorbed here, they can exhaust the entire system. That means no more pollutant can come. So that means you have to remove those pollutants periodically by biological process. So that's what we call biodegradations. So the idea here is that if you have more pollutants here and you have microbial community grow, they will break them down, and because they break them down over time, they will be cleaned by microbial community actions. So that means now these surfaces are more available for removal of pollutant from infiltrated water. So again, just by controlling microbial community, absorption capacity, and hydraulic conductivity, you can improve those treatment capacity of stormwater infrastructures. So this is what I mentioned. Now control the hydraulic conductivity, control the absorption, control the degradations. And now I want to explain to you about specific projects related to your class project. So that's basically potential role of green infrastructures to mitigate negative effect of wildfire. As you know, wildfire is increasing in frequency and intensity. That's because of climate change. With global warming, you have more methane that warm the climate. That warm climate means you have more evaporations, less water. Less water means there are more dry weathers in Los Angeles or California. That means most of the plant die. That create the fuel for wildfire. So that means next time there is a fire, the intensity will be higher. They will spread very quickly. So because of that, wildfire, we have, as you can see over here, wildfire basically takes a lot of these deep behind this residue that's enriched with a lot of pollutants. Because, not just the pollutant in the plants and trees, because many plants has arsenic, copper, other things as micronutrients, so they get enriched in the ash. But now more frequently, wildfire is happening near the urban areas. That means we have also structure burn down that introduce different class of contaminants like heavy high concentration of lead, copper, arsenic, because these are the things that's used in many of the wood materials and the structure materials. So when they burn, they produce a lot of heavy metals. So that means these ashes are rich with these heavy metals and other organic pollutant like polyaromatic hydrocarbon, PFAS. So this will be washed up and polluting the waterways. And we can see that that's why they closed down Santa Monica Bay and beach and other things after wildfire, because all these ash being drained into those systems. So that means we know that wildfire is connected to poor water quality, and will continue to also connect to the water quality, because all these ash are not just in the wildfire area, because they can be spread by wind and deposited in different locations on even far away from wildfire area. So that means if we have stormwater infrastructures, they can basically intersect those contaminated runoff and capture some of the pollutant. That means, having the infrastructure at the roadside at different locations to remove these wildfire ash derived pollutants can improve water quality. So this is just one way, but I want you to think a little bit more. Green infrastructures can also provide more water, the water that can be used for firefighting activities during intense wildfire. So one example, if I want to show you, that in recent Palisade wildfire, now you heard this news that because of lack of water or water tanks running dry, the firefighting activities was not efficient. So why it run dry and where the water doesn't come? And the reason is we have water infrastructures that cannot handle high flow rates. So even when during wildfire, like last time, there are so many different locations people are using water to prevent a fire from spreading, and the pipe will not be able to withstand that kind of flow rate, in the sense that you are using much higher flow rate than what you can supply. So if you have a reservoir, it is not going to supply that quickly. That means you need to have alternate source of water and locally stored, so that can be tapped into. And you know that from the infrastructure, you can basically create a lot of underground network. So what we are going to do today in this class projects, not today, in this quarter, is I'll give you a specific area. This is Palisade area. This is the top of the mountain. Many household there. So you know the area of the house and area of the rooftop. So that means you know how much water falls on those roofs. So you'll calculate how much water comes there, and that will give you access to how much water you can capture potentially per year just from the rooftop. Then we'll design an underground system over there which can be used for firefighting activities. And then you'll also learn how much water you can capture from runoff, which is basically water coming from the roads and on the ground in those areas. If you capture all that, you'll get a volume of water that you capture per year, and then you'll calculate how much water is needed for firefighting time, assuming there is a wildfire in these locations from another 10 or 15 years. So you'll calculate this much volume of water you can capture and how much you can use that time. So, and then you'll also brainstorm how to store that water locally at that location using different infrastructure design. So these are the things you will learn in this class, and you directly apply for this project. So as we go, I'll explain you how we can work on some of the things over time. So again, the part of the homework today is about learning how wildfire can affect the, how wildfire, cause, how wildfire I'm sorry, how a green infrastructure can be used to store water for wildfire. So look at write these two paragraphs when you can, and this is basically contributing towards the projects. So that's basically the learning assessment, how you can apply this. So that's end of the lecture one, and you can watch the next lectures, which will be mostly on pollutants and stormwater pollutions.